Good morning, ladies and gentlemen. I'd like to welcome you to this webinar. My name is Byron Moore, and I'll be your organizer for the session. With me today is Patrick Gordon. I have a short video I'd like to play just before I hand over to our presenter.
There are geezers, grumpy old geezers, and there are electric water heaters. As a plumber, it is important for you to know that you're allowed to install electric geezers provided they're installed according to SANS 10254 and manufactured according to SANS 151. Register for the SANS 10254, the electric water heater online course today to better understand the requirements of this standard, now with a 10% discount. Offer valid 13 to 26 March 2023.
Okay, good morning, everybody. Welcome to this webinar on pressure control valve testing on site. Now, the reason why I did this is I've actually been going to parts of the country, and I'll be covering the rest of the country, also doing like an installer training on how to do pressure control valve testing on site. Now, you may think, why would I do this? Because you guys are all plumbers, you should know exactly how to test a pressure control valve. I'm not trying to insinuate nobody knows how to do the testing. I'm just quickly going to go through some very quick fault findings to try and make your life a little bit easier. We often, as a manufacturer, get valves coming back as so-called faulty, and when we have a look at them, it's actually nothing wrong with them. It was normal expansion, or it's got dirt and so forth in it. So therefore, I'd just like to go through the information with you. It's not based just on the Cal-Africa products. The information I'm going to share with you is generic to any pressure control valve. So yes, whoever's valve you are using, this is going to be applicable to their valve also. So before we can do any fault finding, like anything else, we need to know how it actually works. Because unless you know how a thing works, you don't know what to do with the symptoms you're getting. You don't know where to even go and have a look. Very briefly, we'll discuss balanced water pressure. We'll have a look at a quick fault finding, and that's the main thing for the webinar tonight. And then what to do to recommission the valve after you've actually worked on it. So your operating principle is such that when you get the valve, it is always in the open position. The reason for that is, and let me just quickly get my pen going here. If you have a look at this, okay, the pen doesn't seem to be want to work. Don't worry. This main section, you can see where the spring is there. That is holding the diaphragm in the open position. And there's nothing resisting that spring from doing so. Then once your water is coming in from upstream and flowing downstream, there's water pressure building up underneath the diaphragm and starting to oppose the pressure of the spring. When you now close any faucet or tap or whatever you've got downstream, if you close that, the water then starts building up the pressure underneath the diaphragm, and it forces against the spring until such a time as this main seat at the bottom actually closes and no more water can come through. So to get water underneath the diaphragm, different manufacturers have got different ways of doing it, but there will always be a little bypass port either in the body on the side, or in this case, you can see the picture underside of the cartridge. There's a little hole there. So some way they will get the water pressure from downstream, and it's important from downstream to underneath the diaphragm. If it was from upstream, it would be difficult to then gauge what's happening in the system. So it has to be downstream of the system, check what the water pressure is, and then close the valve at the appropriate pressure. So there you can see it now on the left-hand side picture as the water then flows through. There's no water flow happening. You'll see your upstream has got a higher pressure. In this case, it's looking at about 8 bar pressure. Downstream is at about 3 bar pressure, and the spring has been compressed to such an extent that the main seat is now closed. As soon as you cause water to flow, your downstream pressure now drops, which will relax the pressure underneath the spring. The spring will force the spindle open and allow water to then flow through. You will see that on your upstream pressure, it's hardly affected any pressure there. Well, that would be dependent on what the flow pressure is of the system. But normally your upstream pressure is not going to vary much with your tap or whatever open downstream. So that's the operating principle of it. So we can see then as soon as there's water flow, it relaxes. As soon as the pressure builds up, and we'll have a look just now at what pressure you can expect the water to shut off then, or the water pressure flow to shut off. So if we have a look at then what is balanced water pressure and how can you test for it? Normally you would test any water pressure or balanced water pressure at a mixing point, because you can't test it at an outside garden tap. If you use pressure gauge on an outside garden tap, you're normally going to be getting your upstream water pressure, because your pressure control valve would or should be installed downstream of any high draw off area, such as a garden tap. So we can't test pressure there. You could test pressure at a mixing point in the house, like in a kitchen zinc mixer, but most gauge sets do not have an adapter that will fit on the front of that mixer. So preferably you would use a shower head, unscrew the shower head. Your gauge set will have an adapter to go onto the 1/2-inch BSP there. So even though, yes, you could test it at any other mixing point, if you don't have the appropriate gauge set, you're not going to be able to do it there. So balanced pressure is when your hot and your cold water is at the same pressure. I've heard people saying, yes, I've got balanced pressure, Boast vacuum breakers on 300 high, and all sorts of things like that. But no, it's only balanced pressure when the hot and the cold is of the same pressure. Now, in many instances, you cannot balance it properly because it being an old installation, and you can't take the hot and the cold off the same pressure control valve. In an instant like that, you would then end up with uneven pressure, but you can balance it by putting two of the same pressure control valves, one on the hot and one on the cold water feed, which would then bring you very close to being exactly the same pressure. And that would be suffice for a balanced pressure installation. The reason why you also want balanced water pressure, I'm sure you guys have seen inside of a hot water cylinder, and not as a geyser like we saw earlier, a geyser being a grumpy old man, but a hot water cylinder, there's a lot of gunk inside there. So when your higher pressure cold water pushes back, it goes through the hot water cylinder, brings all this dirt into suspension and dumps it on the inside of the valve. And then it doesn't go through the strainer that's incorporated in any pressure control valve, and it can now go and sit on your main seat or the relief valve seat and cause it to malfunction. So it must be balanced afterwards so that you don't get dirt going on the wrong side of the valve here. Okay, so if we have a look at the process of elimination, first we've got to establish what the problem is and what is causing the symptom of the so-called failure. And then once we've then established what the symptoms is that's causing it, we can then understand why the item failed or the system failed, because often it's not the product that failed, but the system that's now failing. A very quick testing procedure is when you get out to your vehicle, you don't even take your toolbox out yet. First thing you do is go and turn off the hot water or the electrical supply to the hot water cylinder. Now, you may wonder now, why do I want to do that? Because if it's expansion or if it's dripping due to expansion, as soon as I turn off the electricity to the hot water cylinder, it should stop dripping almost immediately. Because water is not compressible, it's going to stop dripping immediately. Just a tip, if you do have a look at the outlet of the valve to see if it has stopped dripping, don't look at the end of a gutter, the outlet of a gutter, because often the inside of your gutter has got a lot of grass and gunk in there, which acts like a reservoir, and the water will percolate out of there slowly, trying to drain. So actually have a look at the outlet of your expansion valve pipe there. If then the water has stopped dripping, we know you don't even have to do anything. You haven't taken tools out, nothing. You now know it is expansion and there's nothing wrong. We can then have a look and see if it hasn't stopped dripping. Is it a balanced water pressure installation? The very quickest way to have a look is to see if there's a cold water takeoff after the valve or before the valve. Now remember, if you get to a hot water cylinder and it's got a non-return valve on the outlet of the geyser, because often the insurance companies insist if it's unbalanced pressure to fix the installation by putting a non-return valve on the hot water outlet of the hot water cylinder. That does not fix it. We all know that a non-return valve is only as good as the seal that's inside. And as soon as some of that gunk and so forth has now ended up on the seat of the non-return valve, your back pressure is back immediately. So if there is a non-return valve on the hot water outlet of the geyser or the hot water cylinder, we know immediately it's most probably going to be an unbalanced pressure installation. But before we do anything now, the quickest way to see if there's back pressure or not is to close the isolating valve that actually feeds the water to that part of the installation. So by turning off that water supply or that isolating valve, you're preventing any more water from coming into the system. So if it stops dripping, we know immediately there's something wrong with that portion of the hot water cylinder installation. Because we've shut it off, it stops running. If it does not stop dripping or running, there's no more water coming in from that side. So we know there must be back pressure from somewhere else coming in. So up until this point now, we haven't actually taken out any tools. You may have taken out a ladder just to have a look and see where the hot water cylinder's takeoff comes off. If it's after the cold water takeoff, after the valve, whatever, is there a non-return valve? So you haven't done anything physically yet. Now you may ask, the valve is dripping. You've made sure that it is expansion taking place, but the homeowner says it is excessive. How much is excessive? Well, there's this little formula that you can see on your screen, H minus C times L times 0.0004. What that means is by how many degrees Celsius have you increased the temperature of the water? Also, how many liters did you heat up? So it's not the size of the hot water cylinder, it's how many times or how many liters you've actually used, times 0.0004. So if you've taken 1 liter of water, you've raised the temperature by 1 degree Celsius, you are going to get 0.0004 liters of expansion taking place. If you look a little bit further down on the page, you'll see in my example, I've said we're heating the water up to 65 degrees. It came in at about 10 degrees. I heated 175 liters of water times the 0.0004. And in this instance, we can expect 3.85 liters of expansion taking place. But the customer says to you, but look at this big puddle of water that it makes. If you take a cup of water and you pour it on that same surface, you will see that it makes quite a big pool of water. So a cup is only about 200, 250 mils, depending on how big your mug is. And in this instance, it's almost 4 liters of water that's going to drip. So there's going to be a big puddle. If you are getting a customer complaining about puddling or moss growing and so forth, because it's dripping, but it's expansion, it tells you one thing: we haven't complied to one of the 10 rules for a expansion pipe, the outlet of an expansion pipe from the hot water cylinder, because it says there it must go where it is not a nuisance. So there is a opportunity for you to then get a little bit of work so that you can reroute the pipe to a place where it's not going to cause an irritation to the customer. Just a quick one. Sorry, I forgot to mention just now, when you're turning off the electricity to the hot water cylinder, make sure that there isn't a solar system connected to it. Because if you turn off the electricity, but there's solar, you're not actually turning off the energy heating the water. So in that instance, you may have to put a blanket over the solar panel or something like that to then make sure that you're not getting any heating taking place. So normally when you go out to a valve, it says it's because the valve is leaking from the overflow. If we then go and have a look and see, is the set pressure of the valve correct? So on a 400 kPa valve, you can expect the pressure, the set pressure, to be around about 300 kPa. If the set pressure is correct, then we know that the problem is by the relief valve. So we then got to check the expansion relief valve to make sure that it doesn't have dirt on or gone faulty or something like that. If you've fixed that and cleaned it out, or whatever you need to do, replaced it, and the valve is no longer leaking, then you know you have got success there. If the set pressure is not correct, we've got to have a look at the main seat, because it tells us that for some reason the pressure is not stopping where it's supposed to be. And then we've got to go and have a look at the main seat on the cartridge. All the valves have normally got a cartridge section. Unscrew that. Have a look and see at the main seat for dirt on there, that it's not sticky, anything like that. Fix that up, replace the cartridge if necessary, and now you should have a valve that's not leaking from the overflow. And that's how easy it is. If we understand where the problem is coming from, you can actually then see, is it the expansion valve that's not working properly, or is it the main seat that's not working? Those are the only two places the valve can go faulty. It's very seldom that there's anything wrong with the brass body of the valve. So normally, even if there is something wrong with either the main seat or the expansion valve, you can leave the valve in situ and just replace the component that has gone faulty and recommission the valve. So there's your valve in position. It's a balanced pressure installation. In this instance, I'm getting about 300 kPa set pressure, so I know it is correct. If you do not have a gauge set, make sure that you get a good quality gauge set. In this instance, this one has got 2 extra adapters, so that you can actually go onto the front of a zinc mixer or on the end of a basin tap or basin mixer. So it just gives you more places where you can actually then test for your pressures. Once again, if it's a washing machine tap downstream of your pressure control valve, yes, you could check the pressure there. But if it is a garden tap that is before the pressure control valve, you can actually only check for mains pressure there. Just quickly, the chart of what pressure you can expect from a pressure control valve. And you will all know that all pressure control valves are color-coded: blue 400 kPa, black 200, brown for 300, red 400, green 600. And it's going to be very difficult to remember all these values. So the important one to remember is 100 kPa. So 100 kPa, your set pressure is between 70 and 85 kPa. The relief is at 95 to 100. Now that is actually a percentage ratio, because if you have a look at a 70% of a 300 kPa valve gives you 210 kPa. 85% gives you 255 kPa. And that is not just because that is where our, as Calafrica's valves are set. These are pressures that are set out in SANS 198 for pressure control valves. So all of your pressure control valves should be operating within those parameters. To do maintenance, obviously, you're going to have to isolate the water to the system, turn it off, open the valve, make sure that you're cleaning the system out. You now already know where to go and look for the fault, and then recommission it. Put the whole thing back together again and test it. Test it to what? Go back to your chart, maybe print it out and have it inside your toolbox, laminated or something like that, and go and check that it complies to all those pressure ratings. This is just a summary of what I've just said. So that is how easy fault finding on site on a pressure control valve is. I often get people that replace a valve and then come back and say the valve that they got is faulty. And I'll ask them, my first question is, why did you replace the valve? Because the previous one was leaking. Why was the previous one leaking? No, it was old. It's not always the scenario, guys. Remember, even if it's an old valve, go and have a look and see why it failed. You can save yourself a lot of hassles. Often something else has changed in the system. Either they've now put flow restricted outlets like shower roses and aerators in a system, making balance pressure installations worse. Anything like that. So establish first, before you change any valve, go and have a look and see why it is giving you the symptoms that it is. So that is all I can tell you today. And I see there is one question that has come through. Byron, I don't know if you want to just go through the questions for us.
Sure. The question says, I usually give the paper of the TCV spec paper. I explain there will be more or less 5 to 10 liters per day. So I guess you have animals like a dog, put a root tip cut underneath, and the water will be filled out automatically.
Okay, I think that's not really a question, that's more a statement. What they're saying is that if you are getting a fair amount of expansion, take a dog's water bowl or something like that, put it underneath, and your animal's water bowl is then being topped up the whole time. That could be one way of eliminating where it is an irritation, but maybe not 100% the correct way of doing it.
We don't have any other questions. Ladies and gentlemen, if you do have any questions, please post them in the Q&A. But thank you very much for this morning, Patrick. Is there anything you would like to add, Steve?
No, I think most people have got my contact details. If not, get hold of IOPSA. They will be able to give you the details. And if you want further information or more in detail training, physical training, by all means, give me a shout and I'll be just too willing to help you to get that going.
All right. Thank you very much. I think we can end with the session there. Thank you and have a blessed week.